We're going to be talking about factoring quadratic trinomials when the a value is not 1. We're going to start with when the a value is 1, just to kind of refresh and compare. So I'm going to do an example over here where the a value is 1, and then compare that to here where the a value is not 1. This is the not equal to symbol. I know it looks like two people frowning over a lake or something, but anyways, it means not equal to. When the a value is 1, you want to find two numbers that multiply to c and add to b. And if you write out the factors of 40, it's really helpful to just divide. Like 40 divided by 1 is 4. 40 divided by 2 is 20. 40 can't divide by 3. 40 divided by 4 is 10. 40 divided by 5 is 8. Those are all the factors of 40, because 40 can't divide by 6 or 7, and we've already got 40 divided by 8 right here. Well, the pair that adds up to 13 is this. So it becomes x plus 8, x plus 5. That's how that factors. And if you wanted to check, you could redistribute all this. There's x squared, there's 5x, there's 8x, there's 40. You get x squared plus 13x plus 40. That's how I check, making this my factoring. Well, if you're factoring when the a value is not 1, you still want two numbers that multiply to c, but they have to be numbers that combine with a to add to b. Meaning, it's not just going to be two numbers that multiply to 40 and add to 21. There aren't two numbers that multiply to 40 and add to 21. However, when I try and factor this, I know that in one of these parentheses sets, I call these bubbles, in one of these bubbles, one of these has to be a 2x, and the other one's an x. You have 2x and x instead of just x and x. Because, if I were to FOIL this, 2x times x is 2x squared. So one of those has to be a 2x. That means that whatever number is going to go into this slot right here is going to get multiplied by 2 whenever I check to do my FOILing. So when I say it has to combine with a, that means whatever number goes here multiplies by this a value. So the factors of 40 haven't changed. They're 40 and 1, 20 and 2, 10 and 4, 8 and 5. And everything's positive, so I don't have to worry about negatives right now. Well, none of these things add up to 21. But this value here isn't 1, so I can play with this 2. And you can start trying things, like if I put a 4 here and a 10 here, that's 8x plus 10x, and 8x plus 10x is 18x, which is not 21x, so that doesn't work. Try something else. What if I did 5 and 8? Like if I put the 8 here and the 5 here, 10x and 8x is 18x. That's still not 21. But if I put the 8 here and the 5 here, there's 16x plus 21x. So it becomes 2x plus 5 times x plus 8. If I were to FOIL this to check, I'll get 2x squared plus 16x plus 5x plus 40, and those combine to get me my 21x, so it checks. So you want two numbers that multiply to c but combine with a to add to b. And I could have said that over here, that multiply to c and combine with a, because the a value is 1. So combining with a isn't very hard. So we don't really worry about it with the first example, but when a is not 1, it becomes a bit more complex. So just here to do a couple more examples. I know in my parentheses my options are 3x and x. And so because 3x times x is 3x squared. Well, the factors of 12 are 12 and 1, 12 divided by 2 is 6, 12 divided by 3 is 4, and that's everything. Whatever number goes in this spot gets tripled. Oh, and this has to be negative because that's negative. Well, I'm thinking about like multiplying one of these numbers by 3 and adding it to the other one. And if I multiply this by 3, I put the negative 3 here and the negative 4 here. There's negative 9x minus 4x to get negative 13x. And don't forget, here's our 3x squared. Here's our plus 12. So we get all the pieces we need. We have a positive 12. We have a 3x squared. We have negative 13x. This is how that factors. 3x minus 4 times x minus 3. What's really nice about watching on a video is you can pause and rewatch something or slow it down or see it again. But what you can also do is pause and try this problem before I do it. So if you want to try it now, pause it and do it. That'd be a very good studying tactic with which to work. So by now you've had a chance to pause it and do it. My options in the bubbles are either 4x and x or 2x and 2x. Now in this case I have two options because this number is not prime. When it was 3, that was prime, and when it was 2, it's prime, but 4 has two options. Luckily this number is prime, so my only options are negative 3 and 1 or negative 1 and 3. I'm going to add to negative 1. If I put a 1 here and a 3 here, and I don't care positive or negative, it doesn't really matter right now. There's negative 6 plus 1 to get negative 5. That's not going to work. In order to switch the signs, they just become positive 5 instead of negative 5. Or 4, sorry. 6 minus 2 is 4. This is negative 4, not negative 5. That's not working. But if I put the 1 here and a 3 here, and I make this negative and this positive, that's not going to work. Negative 12 plus 1 doesn't work. So I'll try it the other way around. 4x and 3, x and 1. I want it to come out negative, so I'll make this negative, because there's negative 4 plus 3, and that's how it factors. 4x plus 3 times x minus 1. Last example, this one we can pull out a GCF first, meaning every term has something in common that I can pull out of it. Everything has at least one x, everything can be divided by 2, and since the leading coefficient is negative, I'm going to pull out a negative 2. Whenever you factor out a GCF, if the leading term is negative, pull out a negative. So if I factor out a negative 2x, this is my GCF is negative 2x, I'm going to get 2x squared plus 9x plus 9. I divided everything by negative 2x and pulled it out in front. Now I'm going to factor this. I can do 2x and x. 3 and 3 multiply to 9. So here's 3x and 6x. 3x and 6x are 9x. This gets me 2x squared. This gets me 9. Checks. So this is how that factors. The negative 2x just sits out there in the front. It just hangs out. If you have any questions, please leave a comment or let me know. Otherwise, you have a great day.